Welcome to the video lecture series of Grade 10 Chemistry. Today we will look into the first lesson, Chemical Reactions and Equations. So, I'm going to explain what are the main topics we should study in this lesson. So, first of all, we have the topic Characteristics of Chemical Reactions. So, here you should study how do we know that a chemical reaction is happened. For example, burning of magnesium ribbon. You already know that. After burning, you get a white ash as the product. So, how do you understand that a chemical reaction has happened in this case? Or you can consider another example, the reaction between zinc and dilute sulfuric acid. So, how do you know that a chemical reaction has happened? Or you can consider another reaction between lead nitrate and potassium iodide. So far, I told three reactions. The first one is reaction uh, of magnesium. Magnesium ribbon is burned in air. Okay. Second one, we consider zinc and sulfuric acid. And then third one, the reaction between lead nitrate and what is the formula of lead nitrate? PbNO3 twice. Lead valence is 2. So you are writing on nitrate side. The nitrate valence is 1. The formula of lead nitrate is PbNO3 twice and potassium iodide. So during these reactions, what are the changes happening? Accordingly, we come to know that the reaction has happened. So that is our first topic, characteristics of chemical reactions. From these reactions, you can generalize some characteristics so that we can say the reaction is taking place. Okay, so these are the three important reactions you need to consider. Now, the second topic is balancing of chemical equations. So here we are going to study about how to balance a chemical reaction. So there are two types of things we are dealing with. First one, you have word equations. The you will have some kind of weight equations. From this weight equation, we are generating or we are writing chemical equations, and then we will balance according to law of conservation of mass. Okay, then you have to repeat and practice with the different examples. So that's about balancing of chemical equations. And then the third important topic is types of chemical reactions. Here we are classifying different chemical reactions into categories like combination reaction, that is the first one, combination, and then combination reaction, and then we have decomposition reaction, decomposition reaction, and then you have displacement reaction. Displacement reaction actually one more type we have. This is single displacement and we have double displacement. Then you should study redox reactions. Redox reactions. So these are the important types of chemical reactions you are studying in this topic. Combination, we have different examples like reaction between calcium oxide and water, that is called a slaking of lime. So you get a slaked lime, and then whitewashing of wall, and then you have burning of coal, formation of water from hydrogen and oxygen. And also in this category, you will be studying exothermic and endothermic reactions also. This is actually based on the heat generated or heat used during the reactions. So in addition to this, you have a small topic called exothermic. Maybe you have studied this topic in your lower classes. Exothermic as well as endothermic. Exo means heat is liberated and endo means heat is used during the reaction. Okay. So we have some examples for exothermic and endothermic. And then we have The last topic is, before the last topic, we will say something about decomposition. Decomposition is actually uh, opposite of our combination reaction. There are three different examples you should study: decomposition of calcium carbonate, ferrous sulfate, and lead nitrate. And then electrolytic decomposition we have, and then photolytic decomposition. So decomposition we have three types. I mean, three types. So one is thermal decomposition, second one is photolytic, and third one is electrolytic decomposition, which means that there are three different types of energies used for the decomposition of a substance. You can use heat energy, you can use electrical energy, you can use sunlight. So accordingly we classify these reactions: I mean thermal decomposition, photolytic decomposition, or electrolytic decomposition, and you should study different types of examples according to the category. And then we have single displacement reaction. There you will be studying about reactivity series. Once you know the reactivity series, it is easy for you to classify this decomposition, I mean displacement reaction, into single displacement, or whether the displacement reaction is taking place or not. And then you should have studied about double displacement reaction. It's also called a precipitation reaction because there is some kind of precipitate is formed over there. Okay. Now, after that, you have to study redox reaction. It's a new concept you studied. I mean, you're going to study. This is a combination of reduction and oxidation reaction, where you study what are oxidizing agent, what is reducing agent, and which compound undergo oxidation, which compound undergo reduction. Okay, accordingly, we study that also. And then lastly, we have effects of oxidation reactions in everyday life, like corrosion of metals. It's a very small topic. We'll study this in detail in your third lesson, metals and non-metals. But still, if we are introducing a little bit corrosion of iron, and then corrosion of copper, and corrosion of silver, only on the peripheral parts of the corrosion, and then rancidity, uh, like the smell or the taste of the food materials change after, or you left it for a long time. So what is the reaction happening, and how do we prevent this oxidation of food substances? What are the methods we are using to prevent this oxidation? So that is called the effects of oxidation in everyday life. Okay, that is related to our daily life situations. So this is actually a very small lesson. If you cover these types of chemical reactions, this is only a little bit topic. Otherwise, the reaction, this lesson is very small lesson. But the important thing you should understand that in order to study this lesson effectively, you should know something which is called the prior knowledge. For example, this reaction is completely dealing with the chemical reactions. So you should know what are the prior knowledge you should understand. You should know already. That is called a prior knowledge. So you should understand the symbols of the elements. First 30 elements in the periodic table. First 30 elements. So you study the first 30 elements name, okay, name, and then their valency. Name means symbol, okay, should know the symbol, and then valency, and then how to write the formula of the compounds. This you have already learned in grade 9. Formula of this compound by using crisscross method. For example, lead valency is 2, a nitrate valency is 1, NO3 valency is 1. So to derive this compound formula, what we do, we will crisscross this. So we will crisscross in this way. So you get to the valency and the formula accordingly. So PbNO3 twice. This is lead nitrate. So potassium iodide, potassium valency 1, iodine valency also 1. So when you crisscross, you will get K1 I1. So you can write simply as Ki. So to write this chemical equations fluently, you should understand the symbol, also their valency, and then how to write a formula. If you know all these three things easily, then this lesson will be easy for you. Or else you would be feeling little difficult. So you study your grade 9 lesson very well. If you already studied, then no issues. You can just revisit the concept again. Just go through the symbols and then their valency and their formula. So then the lesson would be very easy for you. Okay. So in the next uh, concept, we will be discussing the three different types of reactions, and reaction of burning of magnesium ribbon, and then uh, reaction between zinc and sulfuric acid, and then third one, reaction between lead nitrate and the potassium iodide. And we'll discuss these three chemical reactions, and then we will derive how do we generalize so that we can understand that the chemical reaction is happened. Okay, fine. Now, let us look into details of lesson characteristics of chemical reactions. So, to understand the characteristics of chemical reaction, there are three experiments are given. The first, these are the activities given in the textbook. Okay, so these activities, the first one is burning of magnesium ribbon. Okay, so when you look at this diagram, you can already see that magnesium ribbon is burned, and there is a white color ash is obtained during this burning. Okay, now see, you should understand that what are the things are basically asking from this activity. That is how we are studying in a lesson. For example, this magnesium ribbon is burned. So the reactants we have taken as magnesium ribbon. When it is burning, after some time you get a white ash. That is actually magnesium oxide. You can collect this ash in this watch glass. Okay. So the question usually asking in this activity is, can you write an observation based on this experiment? So which observation will you write, or how do you write an observation for this kind of experiments? So observation means what do you see when this experiment is happening? You can see that white ash is obtained. White ash is obtained. So that will be your observation. I'm writing here white ash. White ash. So that is your observation. You don't want to write that migration ribbon is burning. Nothing. But during this reaction, what did you observe? So you observed that you can see some white ash on the watch glass. So the next question can be what is an inference? Inference means a conclusion of the experiment. How will you conclude? Or what did you conclude from this experiment? So you can say magnesium ribbon reacts with the magnesium ribbon reacts with the or magnesium ribbon is burned in oxygen, burnt in oxygen and form magnesium oxide and form a white ash. That is magnesium oxide. Then, how will you write a chemical equation for this reaction? So, magnesium symbol is Mg and it combines with oxygen and form magnesium oxide, MgO. So, why did we write the formula MgO? Because magnesium valency is 2 and oxygen valency also 2. When you crisscross this, you will get MgO. Okay, now the things are clear, but you have not balanced this equation. That we'll be learning in the next topic only. Still, I'm just trying to balance. There are two oxygen. These are called reactants, and this one is the products. So there are two oxygen on the reactant side. So, but product side we have only one oxygen. So you need to put two over here. So now oxygen is two, but at the same time magnesium number is also increased. So you have to balance magnesium also. So 2 Mg plus O2 will give you 2 Mg. So this is the experiment of magnesium ribbon burning. So when you burn magnesium ribbon, you can see a white ash which is collected in the watch glass, And the inference you write is magnesium ribbon burn in oxygen and form a white ash. That is magnesium oxide. The chemical equation is 2Mg plus O2 will give you 2MgO. So from this reaction, how do you know that a reaction is happened? The magnesium ribbon is completely burned. So you get a new product here. So this is one of the characteristics of chemical reactions. A new product is formed. And the magnesium ribbon is already solid in state, and this magnesium oxide also solid. So there is no change in state, but a new product is formed. Okay. Now we go to the next experiment given in the textbook. That is reaction between zinc and sulfuric acid. So this is activity 1.3. Now we are discussing in the textbook. Activity 1.3. So you can see some zinc granules kept inside the conical flask. This is conical flask, and there is a cork. This thing is the cork, and there is a glass tube. And dilute sulfuric acid is taken. There are two reactants now we have. One is zinc granules, and the second reactant is dilute sulfuric acid. So this is a reaction between zinc and sulfuric acid. Okay. Now, what will you see when the reaction happens? So we put zinc granules and we have added dilute sulfuric acid. You can see some kind of bubbles. When you look at this diagram, you can see some small bubbles are formed. Okay, what is this bubbles? What are these bubbles actually? These bubbles are hydrogen gas. So when a metal, zinc is a metal, when a metal reacts with the sulfuric acid, hydrogen gas is liberated. So what is your observation here? Your observation is bubbles are formed. You can see bubbles. Your observation is bubbles are formed. Now, what are these bubbles actually? So, zinc reacts with sulfuric acid. What is the formula of sulfuric acid? Sulfuric acid formula is H2SO4. Zinc reacts with the sulfuric acid. H2SO4, bubbles are formed. What are those bubbles actually? These bubbles are hydrogen gas. Hydrogen gas is liberated along with a product. So how do we write this equation? Zinc plus H2SO4, you will get the products hydrogen gas. It is liberated. I'm just drawing an arrow showing upward. Usually when the gases are liberating, we will be showing an arrow upward. Plus the second product is zinc sulfate. So this is the salt. Salt is zinc sulfate. The second product. So in the inference column, you can add one more point. This is the first point you are writing. Second point, you are getting zinc sulfate. Hydrogen gas is liberated and zinc sulfate also formed. Your second product is zinc sulfate. Is that then SO4. So these are the two products formed during this reaction. So we wrote an equation also and we check whether the equation is balanced or not balanced. If zinc reacts with the sulfuric acid, the product will be hydrogen gas and zinc sulfate. So usually I could see some questions during the board examination. The first question they can ask an observation. Okay, what will you observe during this reaction? You say bubbles are formed. What are those bubbles? These bubbles are hydrogen gas. That's one question you can expect. Okay, so these bubbles are hydrogen gas. Now, one more question I could see related to this experiment. They asked, the board has asked, why did we keep this glass tube? And why they have not dipped the glass tube into this acid? You can see it is placed only on the cork. It is not coming down and touching on the sulfuric acid. It is not touching on the sulfuric acid. Why? What must be your answer? Because this glass tube is used for collecting which gas? You already know, collecting hydrogen gas. So if you put this glass tube into the acid, cannot collect the acid. Okay, that's why the glass tube is immersed, not touching on the sulfuric acid. This question also asked during one of the board examination time. And they already asked how do we write a chemical equation for the same that you already know. Zinc plus sulfuric acid will give you is that an H2SO4 plus H2. Along with the hydrogen gas, you get a salt also. But what is the salt? The salt is zinc. Okay. Now there are one more experiment which is given in the textbook. This topic that is actually reaction between. This is actually 1.2 activity 1.2 from the textbook. Take lead nitrate solution and then add potassium iodide. What did you observe? Actually, this experiment I have done in my practical lab, and the video link I will be providing to you in the description box. You just go through that video also so that you will understand how this experiment you can do very nice way in a very nice way so that you can see the precipitate very easily. So I recommend all of you to watch that video also. That will be stucking into your mind because these are all practical experiments. So when you go through that videos, you will understand what is happening actually. That will be remain in your mind for a long time. Okay, now this will be your observation. So lead nitrate, we have taken potassium iodide. Actually, this reaction is an example of double displacement. We have taken two separate reactants and then we mixed both those. So I'll be writing the equation first, or I'll be writing the lead nitrate word equation. I will write first. So that will be helping you. Lead nitrate. Okay, lead nitrate reacting with the potassium iodide. Potassium iodide. So these are the two reactants we have taken. Okay, tell me, how do you find the product this time? You should exchange the ions. So lead here will be, this lead will be reacting with the iodide and form lead iodide. So your product will be lead iodide. Okay, then one more product will obtain, that will be our next reactant. So take this potassium and nitrate from this side. So your product will be potassium nitrate. Potassium nitrate. Okay. So these are the two products formed. So when you do that experiment, you can understand what is the product actually. But now we are studying theory only. So I will say lead iodide is actually a yellow colored precipitate here. Yellow. So I will use yellow color then. Okay. There is yellow color. So lead iodide is an yellow precipitate. So yellow precipitate will be formed. What is a precipitate? Precipitate is a solid residue formed during the reaction. So this lead iodide will be forming as a yellow precipitate. So this reaction also called the precipitation reaction. And potassium nitrate is actually colorless and it is soluble in water. So it will not forming a precipitate or a solid residue. But lead iodide is a solid residue which is not soluble in water. Okay. So after some time you can see the product will be settling at the bottom of the reaction tube. So that is a yellow precipitate. So in this reaction, what is your observation? Your observation is yellow precipitate is formed. So you can write under the observation column, yellow precipitate is formed. So precipitate I am writing PPT. PPT means precipitate. Okay, what is that yellow precipitate? The lead precipitate is lead iodide. How do we write the formula lead iodide? Lead valency 2, iodine valency 1. When you crisscross it, you will get PbI2. So your yellow precipitate is lead iodide. So what is your inference? For this inference, you should write lead nitrate reacts with the potassium iodide and form lead iodide. We may get or we will be getting yellow precipitate along with potassium nitrate. Okay, and then chemical equation. We'll try that first now. PbNO3 twice lead nitrate because lead valency 2 will be writing on potassium nitrate side. Potassium iodide Ki. Both are having valency 1, that's why I wrote Ki. Now you crisscross this ions. So lead will be combining with iodine. Lead valence is 2, so PbI2 plus iodine valency 1, that will be writing on lead side. Then potassium nitrate, potassium valency 1, NO3 valency 1. So the reaction equation will be KNO3. So PbNO3 twice plus Ki, you will get lead iodide, which is formed as a yellow precipitate. And then you have potassium nitrate, which is soluble in water. We have taken all these aqueous solutions. What are aqueous solutions? Aqueous solutions are the solutions in which a salt is dissolved in water. So all these are aqueous solutions. Okay. Now I'm just writing the state because or else you will have some confusion. Uh, Aqueous solution. So we taken this salt and we dissolved in water. So we have taken AQ. AQ means aqueous. Potassium iodide also AQ. What is AQ? AQ means aqueous. What is aqueous? I told already we dissolve the salt into water. All these are aqueous solutions. So lead iodide may be yellow precipitate. What is precipitate? It's a solid residue. Okay, this will be a solid substance because it's not soluble in water, but potassium nitrate will be remaining in the solution because it is soluble salt, so we say aqueous. So we cannot see that potassium nitrate. So this is the reaction equation for the reaction between lead nitrate and the potassium iodide. Okay, now we move on to this. So already now we studied three reactions. First one is magnesium ribbon, and second one we studied zinc and sulfuric acid, and third one we studied lead nitrate and potassium iodide. So from the above three activities, what are we concluding? We are concluding that, hmm, or what are the observations help you to determine whether a chemical reaction has taken place or not. So you know there will be a change in state. In zinc and sulfuric acid, hydrogen gas is liberated. So there is bubbles formed. So solid is converted to a gaseous state, a change in state, change in color. So in the previous equation, now just we studied yellow color precipitate is formed. So change in color, then evolution of gas, change in temperature. There will be the reaction can be exothermic or endothermic. So if it is exothermic, you know, the reaction test tube will be hot. So there will be change in temperature. So these are the four things which we used to study or which we used to understand whether a chemical reaction is taking place. Okay, so this is our first topic. So far we discussed the three important activities given in the textbook as well as the chemical reaction and how do we do this activity and what are their observations and how do we write the chemical equation. Any, in every examination time you will have one question from this topic. Okay, so we go to the next topic then. Now let us discuss some previous year questions related to this topic. The first one is when dilute HCl is added to thin pieces taken in a test tube. Uh, there are four options given. The first one, no changes take place. Second one, the color of the solution becomes yellow. The pungent smelling gas gets liberated. Small bubbles of hydrogen gas appear in the surface of thin pieces. So you already know that the answer is option B. Even sulfuric acid or hydrochloric acid is added to zinc pieces, hydrogen gas will be liberated. And these bubbles you can see on the surface of the zinc pieces. Now, the second one, take about 5 ml of dilute HCl in a test tube and add a few pieces of zinc granules. This case then they have asked in a different way which gas is evolved. Chlorine, hydrogen, HCl. HCl means hydrogen chloride. Nitrogen. So you already know the gas liberated is hydrogen. Now, the third one, a student burned metal A found in the form of a ribbon. So your key point here is you should not in the form of a ribbon. Usually magnesium is available in the form of a ribbon. The ribbon burned with a dazzling white flame and the white powder B is formed, which is basic in nature. So identify A and B, write the balanced chemical equation. So the important point you should note that the metal which is usually coming in the form of a ribbon is magnesium. So metal A is magnesium Mg, and B is actually the product of magnesium burning in air, that is magnesium oxide MgO. And to write the balanced chemical equation that we already studied, Mg plus O2 gives MgO. This is only the unbalanced equation which you have to balance. There are two oxygen on the left hand side, so you have to put two on the right hand side. So oxygen is balanced. By the same time, you have to balance magnesium also. So put 2 on the left hand side. Now this equation we say it is a balanced chemical equation. Now the fourth question is, why should a magnesium ribbon be cleaned before burning in air? Magnesium ribbon is cleaned before burning to remove the protective layer of basic magnesium carbonate from the surface of magnesium ribbon. When you keep a magnesium for a long time in the atmosphere, it will be reacting with oxygen and form oxide, and it reacts with the moisture to form hydroxide, and finally it reacts the carbon dioxide gas to form magnesium carbonate. So the magnesium ribbon will be coated with this magnesium carbonate. So before burning reactions, combustion reactions, you have to clean the surface of the magnesium so that you can remove the magnesium carbonate, so burning can happen very easily. The fifth question is based on this diagram. Observe the following activity and answer the question. So that is a diagram is given. So you already know this is a reaction between zinc and sulfuric acid. We look at the questions now. Do you observe anything happening around the zinc granules? Yes, you can see bubbles of hydrogen gas. Second one, is there any change in temperature? This reaction happens, the temperature will increase. Why is glass tube not dipped in dilute sulfuric acid? Not dipped in dilute H2SO4. Because this H2SO4 will rise in glass tube, preventing to evolve hydrogen. So hydrogen will not be coming up, or you cannot collect hydrogen gas if you dip the glass tube into the acid. Now, how is gas collected? By downward displacement or upward displacement of water. The gas is collected by the downward displacement of water. Gas soluble or insoluble in water. Hydrogen gas is soluble or insoluble in water. If the gas is soluble in water, you cannot collect the gas separately. So we already used one glass tube for collecting the gas. What does it mean? It means that hydrogen gas is not soluble in water. It is insoluble in water. Now, is the gas heavier or lighter than air? It is lighter than air. Other than this, you should understand that hydrogen gas is highly inflammable. It's a fuel also. Thank you, children. We'll see with the next video.